Base files in Jakarta Enterprise Beans EJB. On database files, the physical files where our information resided on disk. Oracle has several types for data files, each for different purpose. Database data files, control files, online redo logs, parameter files, other database related files. Here you can see EGB architecture. Enterprise Java Beans EGB technology define a model for the development and deployment of reusable Java server components called EGB components. EGB component is a non-visual server component with methods that typically provide business logic in the distributed application. Remote client called EGB client can invoke these methods, which typically result the updating of the database. Since ES server uses COBA IIOP protocols, EGB components running on a SS server can be called by any other type of ES server client or component, even COBA client using ORB from the other vendors that are compatible with COBA 2.3. Here you can see application server. The application server contains EGB container and can contain other features such as web application container to host web components such as Java server pages and Java servlets. ES server is an application server. You can see EGB container. The EGB container runs EGB components and provide required services such as enforcing application security constraints, managing transactions that involve multiple components and databases, and providing naming service that maps components and the resources to the logical names. The container provides the infrastructure required to run distributed components, allowing client and component developers to focus on programming business logic. And not system level code. EGB client. An EGB client usually provides the user interface logic on the client machine. The EGB client makes calls to remote EGB components on a server and needs to know how to find the EGB server and how to interact with EGB components. EGB components and web components can act as an EGB client by calling methods in another EGB component. Session beans and entity beans. EGB components can be of two types. Most applications include session beans to be invoked directly by clients. Session beans provide the interface between base clients and the server-side implementation of the application. Entity beans provide an abstraction of an object that is stored in a database. Entity beans are not typically invoked directly by base clients. All types of EGBs are implemented by a Java class that contains implementations of remote interface methods. And additional methods for cycle management. And client interfaces client interfaces an EGB client does not communicate directly with EGB component. The container provides proxy objects that implement the component home and remote interfaces. The component's remote interface defines the business methods that can be called by the client. The client calls the home interface methods to create and destroy the component's logical name to the proxy objects that implement the home and remote interfaces. The proxies contain generated code required to invoke component over the network. Beginning in EGB version 2.0, EGB and web components running in the same server can execute EGB components using the component local interface. Using the local interface can improve performance. If an EGB component is not meant to be invoked directly by client application, you can include local interfaces for the component. Here you can see a web client is connected to JSP and servlet. JSP and servlet are inside web application container. Web application container and EGB container inside application server. JSP is connected to local home interface and local interface. Servlet is connected to local home interface and local interface. EGB client is connected to home interface and remote interface. Session bean and entity bean are inside EGB container. Session bean is connected to local home interface and local interface. Local home interface and local interface is inside entity bean, and entity bean is connected to database. Here you can see a database storage structure. Here this diagram shows the logical, physical and recovery related structures of the database and relationships between them. Dotted horizontal lines divide the image into three sections. Top section shows logical structure, middle section shows physical structure, and the bottom section shows recovery related structures in the flash recovery area. In the logical the logical structures are all table spaces. Each table space point to a data file or temp file, which are physical structures. Other physical structures include control files, a server parameter file and a password file. Here you can see the physical structures include the control file, server parameter file, and password file, and temp file, and data files. Flash recovery area contains following structures: backup of the server parameter file and control file stored in an archival format called a backup set. Another backup set containing a backup of the data files, other online redo files, redo log files, and archived redo files which are copies of redo log files after they are filled. They are filled. Oracle Database Express Edition, Oracle Database XE, is composed of following storage structures: logical structure, such as table spaces, are created and recognized by the database only and are not known to the operating system. Physical structures are those that can be seen and operated on the from the operating system, such as physical files that store data on disk. Recovery related structures such as redo logs and database backups are used to recover the database after an operating system failure, Oracle instance failure, or media disk failure. Recovery related structures are stored in automatically managed disk storage area called flash recovery area. Oracle Database XE completely automates the management of its logical and physical structures and flash recovery area storage. You use Oracle Database XE graphical user interface to monitor these structures, mostly to understand how much storage your application have used so far, how much free storage remains, and whether more space is needed for backups. So here you can see logical structures, physical structures, and flash recovery area. In system table space, syst or AUX table space, undo table space, users table space, and temp table spaces space are in logical structure here. Control file, server parameter file, data files, temp file, and password files are in physical structures. So system table space, systox table space, undo table space, and users table spaces space are connected to data files. Temp table space is connected to temp file. Here you can see backup set, control file, and password parameter file, and backup set data files. Online redo logs and archive redo logs are in data flash recovery area. Control file and server parameter files are connected to backup set. Data files are connected to backup set with data files, and online redo logs are connected to archive redo logs here. As an here you can see updates to simultaneous databases. The enterprise bean architecture makes it possible for all application program to update data in multiple databases in a single transaction. The following figure, a client invokes the enterprise bean X. Bean X updates data using two database connections that the deployer configured to connect with two different databases, A and B. Then X calls another enterprise bean Y. The bean Y updates data in the database C. The enterprise bean server ensures that the updates to database A, B, and C are either all committed or all rollback. The application programmer does not have to do anything to ensure transactional semantics. Behind the scenes, the enterprise bean server enlists the database connections as part of the transaction. When the transaction commits, the enterprise bean server and the database systems perform two-phase commit protocol to ensure atomic updates across all three databases. Here you can see a client is connected to X, and X and Y are in enterprise bean server. X is connected to database A and database B, and X is connected to database Y. X is connected to Y. Y is connected to database C. Here you can see message sent to Jakarta messaging queue and updates to multiple databases. The enterprise beans architecture make it possible for application program to send messages to or receive messages from one or more Jakarta messaging destinations, or to update message data in one or more databases in a single transaction. In the following figure, a client invokes an enterprise bean X. Bean X send messages. They send a message to a Jakarta messaging queue A, and updates data in the database B using connections that the deployer configured to connect with Jakarta messaging service provider and data and a database. Then X calls another enterprise bean Y. Bean Y updates data in the database C. The enterprise bean server ensures that the operations A, B, and C are either all committed or all rollback. The application programmer does not have to do anything to ensure transactional semantics. The enterprise bean X and Y perform the message send and database updates using standard Jakarta messaging and JDBC APIs. Behind the scene, the enterprise bean server enlists the session on the connection to the Jakarta messaging provider and the database connection as part of the transaction. When the transaction commit, the enterprise bean server and the messaging and database systems perform the two-phase commit protocol to ensure atomic updates across all three resources. Here the client is connected to X. X and Y are inside enterprise bean server. X is connected to QA, and X is connected to the queue and database B, and X is connected to Y, and Y is connected to database C. Here you can see the message sent to Jakarta messaging queue serviced by a message-driven bean and updates the multiple databases. In the following figure, the client sends a message to a Jakarta messaging queue A, serviced by the message-driven bean X, and bean X updates the data using two database connections. The that the deploy configured to connect with two different databases B and C. The enterprise bean server ensures that the decoying of the Jakarta bean Jakarta messaging message and it's received by BeanX and the updates databases B and C are either all committed or rollback. Here the client is connected to the QA and QA is connected to the X. X is in the enterprise bean server. X is connected to database B and database C. Here you can see update to multiple database in same transaction. The enterprise beans architecture allows update of data at multiple sites to be performed in a single transaction. In the following figure, the client invokes at enterprise BeanX. BeanX updates the data in database A and then call another enterprise bean Y that is installed in remote enterprise bean server. Bean Y updates data in database B. The enterprise beans architecture makes it possible to perform the updates to database A and B in a single transaction. When X invoke Y, two enterprise bean servers cooperate to propagate transaction context from X to Y. This transaction context propagation is transparent to application level code. At transaction commit time, the two enterprise bean servers use a distributed two-phase commit protocol if the capacity exists to ensure atomicity of the database updates. Here you can see client is connected to X. X is in the enterprise bean server. X is connected to database A and X is connected to database X is connected to Y. Y is in enterprise bean server. Y is connected to database B. Here you can see updates on multiple databases on multiple servers. A Java client can use jakarta.transaction.user transaction interface to explicitly demarcate transaction boundaries. The client program obtains the jakarta.transaction.user transaction interface through dependency injection or lookup in the beans EJB context or in the JNDI namespace. Client program using explicit transaction demarcation may perform via enterprise beans atomic updates across multiple databases residing at multiple enterprise bean servers as illustrated in this figure. The application programmer demarcates the transaction with begin and commit calls if the enterprise beans X and Y are configured to use client transaction. That is, their methods have transaction attributes that either require or support an existing transaction context. The enterprise beans server ensures that the updates to database A and database B are made as part of the client transaction. Here you can see the client begin and commit are inside the client, and client is connected to X. X is in the enterprise bean server here, and X is connected to database A. Here the client is connected to Y, and Y is in the enterprise bean server, and Y is connected to database B. Here you can see update of multiple databases from non-transactional client. Whenever a client invokes a method on a enterprise beans business interface, on the beans no interface view, on a home or component interface or message listener method, the container interposes on the method invocation. The interposition allows the container to control transaction demarcation declaratively through transaction attributes set by the developer. For example, a session bean method is configured with the required transaction attribute. The container behaves as follows. If the client request is not associated with transaction context, the container automatically initiates a transaction whenever client invokes an enterprise bean method that requires a transaction context. If the client request contains a transaction context, the container includes the enterprise bean method in the client transaction. The following figure illustrates such a scenario. A non-transactional client invokes an enterprise bean X, and the invoke method has required transaction attributes. Because the invocation from the client does not include transaction context, the container start a new transaction before dispatching the method on X. Bean X work is performed in the context of the transaction. Then X calls other enterprise beans Y in our example. The work performed by other enterprise beans is also automatically included in the transaction, subject to transaction attributes of the other enterprise bean. The container automatically commit the transaction at time X returns a reply to the client. If a message driven bean message listener method is configured with the required transaction attribute, the container automatically start a new transaction before delivery of the message and hence before invocation of the method. Jakarta messaging requires that the transaction be started before the dequeuing of the message. The container automatically analyzes the resource manager associated with the arriving message and all the resource managers accessed by the message listener method with transaction. It is illegal to associate Jakarta transaction interceptors with enterprise beans. Here, client is connected to X via begin and commit, which is inside enterprise bean server here, and X and Y are inside the enterprise bean server. X is connected to database A and X is connected to Y, and Y is connected to database B. Example here we configure egb dash jar.xml file. The environment is Oracle application server log. Oracle application server. The employee example define one-to-one unidirectional relationship in which each employee has only one address. This relationship is unidirectional because you can retrieve the address from employee, but you cannot retrieve the employee from the address. Thus, the employee object has a relationship to its address object. The egb-jar.xml file has defined the following. Configure each entity element within enterprise-beans section for each of the entity beans involved in a relationship. For example, this includes entity element of employee with egb name of emp bean and entity element for the address with the egb name address bean. Configure the egb relationship element within relationships section for the one-to-one relationship. For example, it define following. An egb relationship's role element for the employee being that define the cardinality of as 1 as it's at in its multiplicity element. The relationship role source element define the egb name as emp bean, which is the same name in the entity. an EGB relationship role element for the address bean that's define its cardinality as 1 in its multiplicity element. The relationship role source element define EGB name as address bean, which is the same name in the entity. Element. Configure a CMR field element in the EMP bean a relationship that points to the address bean. The CMR field element define address as the address bean reference. This element name matches the get and set method names, which are named getAddress and setAddress. These methods identify the local interface of the address entity bean as the data type that is returned from the get method and passed on to the method. As an example 2, we can consider QA, PM, WA, SE, JB, EGB data. This data includes information about applications with enterprise Java beans EGB running on WebSphere application server. Each record represents one type of enterprise beans per application module per interval. If there is no bean activity for a particular EGB type, then no record is written. As an error example, we can consider exit status 1. Error in executing the subcommand start database. The start database subcommand start the Java DB server that is available for use with Glassfish server. Java DB is based upon Apache Derby. Use this subcommand only for working with application deployed to the server. This is in the environment Oracle Glassfish server 3.1.2 and 3.1.2.2. So this is the end of my presentation. Thank you very much for watching it. Now this is the end of my presentation. Thank you very much for watching it.